course, doing a hands-on workshop today. Before we get to the hands-on workshop, there'll be a presentation part of things, kind of laying the land for how this sits in the security space, things that have been going on in the security world, doing a bit of a tech deep dive, and then we'll get into the actual, we'll look at the Oligo product, but then we'll get hands-on with some exploits and looking at a couple of the great OWASP projects, in particular PyGoat. So that should be a lot of fun. I wanted to ask folks for their opinions on what do you think, what's the worst outcomes of software security vulnerability? What are attackers going for? Any takes in the audience? What, sorry? Money, there you go. So that's definitely one of the things they want to get, but even think a little sooner than that.
Software vulnerabilities and mission critical things mean that hundreds of people die.
That could be a pretty bad outcome for sure. So definitely good answers. If an attacker thinks about a vulnerability that they're going to try and take advantage of, what do they want? Maybe 0 days in a good track. What was, sorry? An exploit, sure. So a type of exploit and a remote code execution exploit is the answer I was trying to go for. I need to work on my question a little bit, I guess. But RCEs are going to be kind of the focus of what we're talking about here. And so the RCE, it lets the attacker deploy whatever code they want in the victim environment, right? So they're getting the keys to the castle in that way. And the problem that we're trying to solve is how do we stop that from happening? How do we stop them from getting that initial access? And there you go. That's what the Oligo is founded on. That's the whole purpose of the company, is to be able to block attackers from getting that initial access. Another big part of what's going on right now is AI. Obviously, you've probably heard of it, played around with it a little bit. How do you think that changes the security landscape?
Research more easily, or also develop exploits easily?
Yeah, definitely lets the attackers research more easily, develop more exploits easily. Any other thoughts that anyone has on that one?
I think it makes both attackers and defenders more productive.
More productive for sure. Who do you think, I'm curious, who do you think it favors, the attackers or the defenders?
Whoever wants to attackers.
I would say favor attackers.
It's going to be interesting to see how it plays out over time.
Oh. You can fix them, but you can't just. You fix one thing, you might break the other code. So I think it's helping us out because I don't think you can fix vulnerability like that.
I think you can go at much faster pace. So we need to be always real time protected.
Faster pace for sure. I agree with that.
One of the things I worry about, a lot of us worry about, is all the really good nation-state attacks have been not duplicated anywhere else. So AI gives us a false security that we can find. But in fact, especially if you're Ukraine, you've lost your power grid 3 times, you find out that the bad guys actually spend a lot of effort to make sure they don't use anything that AI will discover.
For sure, yep. And so, yeah, it's interesting to think about from the defender perspective, from the attacker perspective. I think at the start, at least, it makes things harder for the defenders because they have more to cover. They're kind of already swamped with so many vulnerabilities. And a lot of the tooling at the start was developer-focused, not defender-focused. And so the attackers can use that developer-focused tooling. And just a couple, you've probably all heard of Mythos and Glasswing, the model that the government just shut down from Claude. Definitely helping discover exploits a lot faster, like some of you mentioned, compressing that time that people need to be able to actually take advantage of the exploits. Another thing I think is a big differentiator, different change from all of this. You used to need a fair bit of skill and a sophistication to take advantage of a lot of these exploits, to discover a lot of these exploits. It lowers the bar for the skill an attacker needs to be able to find these exploits and use these exploits, which is another problem for defenders. So definitely a bit of hair on fire situation for a lot of the security teams that we've been talking to. And a lot of teams are doing like war rooms to kind of target Mythos and be able to help defend against Mythos. This just talks about the trend that goes back even further before the AI LLMs were really becoming a big thing. And the amount of vulnerabilities that are out there has been significantly increasing, as well as the time to exploit has been decreasing significantly. So this is a trend that was happening already, and AI is really just exacerbating this trend and making it a lot harder for defenders. Another interesting fact is, what are attackers trying to do to take advantage of companies? How are they trying to get in, really? And so the application as the main target attack vector is now the largest single attack vector. So that's trying to find vulnerabilities in your applications that they can use to hack you versus phishing, other exploits like that. So being able to prevent this at the application layer has significant value for companies, both because exploits are becoming more and more, and because they are becoming the biggest attack vector that hackers are using. Leading us into kind of what's the landscape for tools right now, and what are some things that traditional security tools do see from attackers and are blocking against. Any takes on that?
It's really important to discover abnormalities in your network response.
Yeah.
Be careful saying that, because Darktrace, MOVEit, and Silas all use machine learning to identify what are proper communications through your network. So if they see something different, then they'll be able to identify.
Yeah, definitely. So anomalous network traffic, definitely something. There's a lot of tools out there that are able to look at and understand. And it's interesting to see AI layered on that and how that can impact things. The AI piece? Oh, there you go. Maybe not the LLM side, I guess, but yeah. From an ML type perspective, or?
If you supervise learning, that's what Darktrace uses, where they're watching normal behavior, or when you have something that's abnormal, they use that, they train that deep learning to identify when that happens. Now, MOVEit uses a slightly different approach. So it's whether, are you looking for abnormalities or are you looking for normalities?
Sure, yep.
So those two companies both use deep learning to find anomalies in their own way. And they're both, I think they're both based off of network monitoring like Zeek.
Okay. But yeah, so definitely network is a layer that has some solid security tool capabilities. Any other thoughts on things that security tools often look at? Static analysis, sure. So looking at the code or the binary before it's into production to try and find any weaknesses that way. Yeah, for sure.
I would say dependency security, supply chain risk, as long, those are things you need to know, right? What do you have? If you don't know what you have, how do you protect it?
Yeah, 100%. And we've seen a lot of supply chain attacks with AI and the Team PCP, all of those things. So yeah, understanding your supply chain and where what you're using comes from is definitely important.
If we're talking about traditional security tools, WAFs are one of them. Looking for common patterns, so like regexes.
Yep, for sure. WAFs, looking at payloads, things like that, what's coming in on your network, DDoS, those sorts of things. Also looking at the process layer, the workloads, is there file interactions they're not expecting, things like this. So those are all really useful to look at and things that a lot of security tools are able to help with. Where they're blind a lot of times is at the application layer in production. You might look at the application layer kind of in your static analysis, but that's before you're going to production. And they don't have that context of what's going on inside the application, which is where these RCEs are being exploited by attackers. And a lot of the pieces, so WAF is typically going to be before the exploit, or if you're looking at anomalous network traffic, that's post-exploit a lot of times when they're trying to reach out to command and control servers or things like this. You could also look at post-exploit activity, like trying to harvest credentials, trying to interact with the file system, things like this. And so a lot of security tools cover that, but that means the attacker has already gotten in. They're already potentially doing damage to your systems. So if you can stop them at the application layer before they get in, that's a huge advantage. This slide just walks through what are some of those different areas that the attacker gets to. And so a lot of the things that we talked about, the initial access though, that's where we really want to stop them if we can. Then they're executing code once they're on there, trying to get root privileges if they can, then trying to get persistence, do all the bad types of things that they want to do, whether that's a crypto miner or just take things down, all of that. But if we can stop them at that initial access, at that RCE level, that prevents them from doing any of the activities that happen after the fact. And so it's much better than trying to detect them based on the signals after the fact. And that is where the Oligo tool comes in. Definitely a weakness that our founders saw and thought we could really help to plug that gap for folks. I want to talk a little bit about the specifics of what we're looking at and how it all works. And I thought you were going to mention eBPF earlier, actually, the way you were talking about the network. But eBPF, are folks familiar with eBPF in the room? Extended Berkeley Packet Filter is what it stands for. It's a Linux kernel technology that's been out for a little more than a decade, and it's based on giving safe kernel access to programs so that they're not accidentally going to crash the system. They're not going to corrupt memory, things like this. Your application is verified before it, verified to make sure it's eBPF compliant before you launch it. And then it's effectively kind of an API, a sandboxed API to get that kernel access in a more safe manner. It is highly performant as well as safe. And so the safety, if you all are familiar with the CrowdStrike airport crashes and stuff like that from a couple of years ago, that's the traditional kernel modules that can bring down the whole system. eBPF is solving that problem on Linux. Microsoft is also doing some eBPF types of things, so we'll see if we get it there as well. And this, I hope the contrast shows up better further back. Might need to fix this slide for the next one. But this is showing just a very simple application. And you've got a code block in the middle, and the code block is all just a black box, effectively. The security tool is not able to see inside of it. Then we have the Linux syscall API and the kernel. And so the syscall API is sitting in between the application and the kernel. And if you look at traditional security tools, this is the view that they typically have. They can't see inside the code, but they can see the kernel interactions that are happening, as well as things like the network layer. And so you've got users that are going to use this application, and the application does a whole bunch of things in most cases. You know, there's good reasons for an application to talk to the file system, to write log files or other operations like this. There's good reasons for an application to talk to the network, maybe to talk to your database, maybe to talk to other microservices that are part of the application. So if you're looking from a traditional tool standpoint, you don't always have enough context to be able to say, is this activity malicious, or is this just a normal part of what the application is supposed to do? Through the visibility that you get with eBPF and through the Oligo, the IP that Oligo has developed on top of that, this opens up what's going on inside the application. So we can combine all of that information about what's happening at the kernel level with what's going on inside the application. What dependency is initiating this network call or initiating this file access request, and down to effectively having all the call stack of the application. So what function within the dependency, or what function within the main application is this coming from? And when you take those two things together, that lets you see patterns and malicious patterns effectively. So if you look at language frameworks, JNDI is a good one, or if you look at serialization in Python, you can understand what is supposed to come from those and what's not supposed to come from those. So creating a new process to execute code isn't supposed to come from JNDI, for example. And so because we have that visibility, when we see that, we can say this is deterministically bad. And you don't need a CVE to be able to do that. Does that make sense? Anybody have any questions about that? Can anybody think of a good JNDI security vulnerability? Log4j, there we go. Definitely, yeah, the most well-known one. And obviously had a very severe impact and had a lot of companies running around trying to understand, where is this in my system? What's going on? So being able to stop that from happening, stop attackers from taking advantage of it, can be a very valuable capability. A few other things that eBPF allows. So we talked about safe and performant already. It's also a very simple deployment. It doesn't need access to source code. It doesn't need, it doesn't depend on the programming language or anything like that. It's all happening at the kernel level. So very easy to deploy compared to a lot of other tools. It can work with any application or any code. This could be open source applications. It could be code you're writing in-house. It could be vendor supplied code. And as I talked about, it can prevent categories of attacks, because these malicious patterns, they effectively map to CVEs. So you don't need, if it's a 0-day, you don't need someone to have gone and figured out all the details so they know what signatures to look for or anything like that. It's just based on the attack pattern. The next thing that I wanted to run through is a product walkthrough before we get into the attacks. Now I see most of you have laptops. How many people don't have laptops? We've got one. Do you want to, most of the stuff now, I'll show some stuff on the screen as well, but it could, if you wanted to buddy up with someone with a laptop, that's an option as well. We're going to look at just a demo read-only environment. And so feel free to, I'll give you all a minute to log in to this first. And
So Jim, in the diagram on the previous slide,
yeah,
how do you deal with the encrypted traffic?
because it's actually happening, we're sitting on the host already. So it's been decrypted already by the time it gets to that environment. It's not at the network layer or anything like that. So it doesn't, we don't have to worry about the encryption. Does that make sense?
What if the application does it in its own?
It shows to see the password.
Oh, the power, sorry. Sorry, what was your question?
What if the application does the encryption in its own memory space?
So what we're seeing is effectively the call stacks, as well as the kernel activity that's resulting from that. So that's
But you don't need to see the data.
exactly, yeah. We will get like some payload information when, so if it's spawning a new process, for example, we will get the payload of what that is, but that must be unencrypted by that point. I don't have a detail exactly on that, but yeah, it needs to be unencrypted when they send it to the kernel, I suppose. So we would get it that way. Yeah. Is everyone good on this screen? Yeah. I will show a little bit. So there's a lot of things that are going on in here, and we're not going to deal with all of them today. But if you hover on the left, then you can expand that out. And there's the incidents and detections side of things. And so specifically detections. And I'm actually in the wrong. I'm not in the demo environment right now. Just a second. What's that? There we go. So the incidents here, these again are just sample incidents to kind of show what things can look like. And you'll see some of them have that blocked tag on them. So those are the ones that are actually blocked. There is a log4j incident in here. And so you get a lot of nice forensic data that Oligo is able to provide, again, that we collect through eBPF. And you get a nice graph of the intrusion, so showing, hey, this is coming from a Java application, using a JNDI library in particular. If I can hover on the right spot, using the log4j core library, which is then going into the JNDI and resulting in a fork call in this particular instance. You can also drill in, and if you click on the timeline view, you can get into the call stack here, which is really cool from a Defender perspective, just to be able to see all that detail.
How did I get to the call stack again? I mean, at the rack. So
If you click on the timeline view at the top, and then if you click on the second one in the timeline view, and then there should be these details section here, and the call stack. And then you can expand the call stack on the right-hand side of that as well. And then you can see all of the, right from the standard library at the top, or well, the bottom, but the initial thing that it's calling, through all of the different dependency code and getting into the JNDI classes specifically. And then Oligo is effectively saying, hey, this is where we're seeing a malicious pattern going from that JNDI, resulting in that fork call. And we can also look at the process tree and see what is actually getting spawned in that, what command is getting spawned in that new process that was getting started. And so it is using this netcat command to establish persistence and get a reverse shell there. And so I'll give folks a couple minutes if you want to explore around in that demo environment. And then after that, we'll get into the actual attack portion of things. I'm going to hand out some sheets. I've got some Google Docs set up with all of the login information for the attack environments. And so I'll hand those out over the next few minutes, and you guys can check out that demo environment and ask any questions as I come around. Does anyone have any questions or anything before I get started with that?
I do have a question on your details. First column, it says ADR, profile violation. What does that mean? Something violated this or what? It's right before the call stack.
Yeah, so ADR is application detection and response. And that's effectively a flow showing what we expect to be acceptable from the JNDI or from whatever place we're starting in, but JNDI in this case, and then saying, okay, it's going off of that flow into what we consider now malicious behavior.
How do you sense the delivery data how it works? Is it software-based or is it hardware-based?
Yeah, it is all software-based. And so it's based on that eBPF that I was talking about earlier. It's deployed one sensor per host. And so we're just targeting Linux environments where production applications are installed right now. Can work in a Kubernetes environment, deploys as a daemon set in a Kubernetes environment, or can work in virtual machines, bare metal, all of that. Very lightweight, so uses about 0.5 gig of RAM typically, and around 1% of CPU performance. And it's looking at, so through eBPF, you can get a hook effectively when certain syscalls are used. And so we're able to use that when syscalls that we are looking at for malicious activities might be used, but we also get access to memory and what's going on in memory. And from that memory access, we're able to reverse engineer effectively the call stacks of the application. So that's how we get both sides of the equation, the call stack component and the syscall, the kernel syscall API information, which gives us the full context of what's going on in the application. Anything else there? Okay. Yeah, so for detection, we support a bunch of languages right now. Olago is about 4 years old as a company, so still building out a lot of the support. From a blocking perspective, today we support Python and Java, and Go and JavaScript are going to be out within the next month or so. From a detection perspective, we support quite a few, all the main languages, so C#, Ruby, C++, what else? There's, sorry, not Rust yet. But Rust is a fairly low attack surface compared to a lot of languages for this, so we decided to, yeah, not prioritize it as high. We'll get there at some point, though.
Why does the language matter? Isn't it just seeing syscalls?
So we don't directly get the syscalls from the from eBPF. We just get access to memory, and then for each language, we have to understand how they lay things out in memory so that we can get that information effectively. So yeah, it does take extra effort for each language to be able to figure it out. But it doesn't, it's language agnostic from like a deployment perspective. You don't have to, yeah, it's not working with the language runtime or anything like that.
So, I'm a person who's spent most of my life doing static languages, like data and all that kind of crap. For Python and languages like that, JSON, those are interpreters. So how do you deal with those?
It's true they're interpreters. I don't have a good answer for you. I know that our team has figured it out and we've got customers using it, but I'm not sure exactly what the difference is in how they're using memory.
Seems like interpreters would be pretty easy to do. And the world has jumped into a wagon of using interpreters for everything, which is kind of, I think, kind of stupid.
Fair. So yeah, I'll have to double check on that one. Otherwise, yeah, I will start handing these out and let me know if you've got any questions as I come around. So is everyone able to get into the Google Docs? Okay. Looking good so far.
Sorry.
This one? How many of you have played with OWASP PyGoat before? It's a really great intentionally vulnerable application. And so we're going to go through some of those labs today. They've got a whole bunch of different labs that you can check out. The two that we're going to focus on today is both from the OWASP Top 10. There's lab 3, which is command injection, and there's lab 9, which is vulnerable. Is it lab 6? I think it might be 6. Anyways, it's an exploit on a old dependency that has a vulnerability in it. And so if we get into the document, you're probably all way ahead of me here, but there were the different credentials for the Oligo UI itself, as well as the test drive server. Are you all logged into the test drive servers at this point? Yeah, perfect. I am going to share a different screen here. For which it's in that Google Doc. So there's a different password depending on which one you had, and let me share. Were you able to get into the test drive password there? Or? So there's different scenarios. The first thing that we're going to do is in the applications side. So if you go into the application tab first, and then there's the PyGoat. So we can launch that application, and you'll probably need to create an account to register. And it doesn't matter what email you use. You can just use any email and it won't send anything to it. Just remember the username and the password so that you can log in to PyGoat. So I'll give folks a second to do that, and I will log into that Oligo instance also. Oh, someone's getting ahead. We've got some incidents already. I had a completely fresh Oligo environment that didn't have any incidents that I set up for this. So as you can see, someone has been running some of the other scenarios, which is okay. That's what we're here for. That's the workshop. But is everyone into PyGoat, or are people still figuring PyGoat out? I'll take that as a we're in. Once you're in PyGoat, if you go to the OWASP Top 10 and then to A3 injection and command injection, and if I'm going too fast, let me know, or this is all in the Google Doc as well. And you can go to lab 2. And so lab 2 is all around the eval function in Python, which is going to directly execute whatever code someone puts into that function. So if you're letting users put in information which you're directly putting into the eval function, you're not sanitizing it first or anything like that, it can execute whatever they send to you. So obviously very bad from a security perspective to do that. But that's what that's set up to show what the impact of this can be. And so if we go here, we could just put a math operation in, and it's going to give us the output from that math operation. But you could also put in different Python commands And so if you look at the Google Doc that we had, there's a whole bunch of sample Python commands. Does everyone see those sample Python commands in the doc? Any no's? I'll take that as yeses. So feel free to take any of those different commands in there. Also feel free to try your own commands to see what's going to happen as you put it in. The first section is just, calling to upper or basic things like that. And I'll do an example up here. So just, a list, and it's going to perform the output of perform the operation and show the output from that Python list command. But you could also use Python to get malicious things or to get sensitive things on the operating system. So you could ask it for the contents of etc password, for example, or ask it for the contents of environment variables, things like this. And so as you're doing these, go back and forth between the environment and Oligo, and then you can see the incidents, or sometimes they'll show up as detections in Oligo. So let's see what people are doing if we're getting very much activity. I should just share my whole screen instead of keep going back and forth. Yeah, create an account, but it doesn't, you can use a fake email or whatever. It doesn't actually send to the email.
Oh, I see. Okay.
Yeah.
And I can log in. No, I cannot log in. Okay, I see.
So I'll give folks, actually, I'll show one thing in Oligo, and then I'll give folks a little bit of time to play with this and come around and see if there are questions. So I'm seeing a few more incidents. Okay. I'll come around and see how folks are doing, and then we can show incidents that are coming from these attacks after we're done with that. We have a bunch of incidents going on. We have a bunch of detections going on. I'm curious, how many people skipped ahead to the next lab? A little bit. All good. All good. I've had a couple people ask me questions about what they're seeing in oligo in general. So I wanted to touch on that real quickly. So I'll show on the main screen up here. If you go to the dashboard, this has a little bit about the 3 oligo product lines. So we've been looking at the application detection and response piece. There's also this posture or vulnerability management piece. So this is looking at what are the vulnerabilities in your production environment. And it can tell you whether the vulnerability or the vulnerable dependency has actually been executed or not. A lot of tools typically look at, has it been loaded into memory? Is it potentially reachable? Because oligo is living on the host itself, it can see, was this actually executed in your runtime environment? That means it's a higher risk for attackers to be able to take advantage of it. Same thing, in a lot of cases, the vulnerable function is known, about 70% of vulnerabilities. So oligo can see, was this vulnerable function actually called in your runtime environment? So really lets you focus in on those things that are the most risk in your environment so you can patch them more proactively. There's also the AI side of things. That's not actually deployed in this environment right now, but is something that we were coming out with. Same idea, being able to see what are all the AI components that are installed across the environment. And sometimes we've had customers get containers from vendors, things like this, where they didn't realize AI was installed. We're also going to be doing AI detection and response. So prompt injection is the first thing that we're starting with. That's going to be looking at, okay, what's the prompt that's coming in, but what action resulted as a result of this prompt? Did something actually potentially malicious or potentially impactful happen or not? Because a lot of things that only looked at the prompts, they are very noisy. They have a lot of false positives, things like this. If you connect the prompt and the action together, that lets you focus in on what's actually a serious issue, what's actually something that you need to do something about. If you haven't yet, let's go ahead and check out the next lab, which is the A6 vulnerable and outdated components piece of things. This is another OWASP top 10 one. And so if you go back into the PyGoat page and OWASP top 10, A6 vulnerable and outdated components, and it's lab 1 in this case, and it's using this PyYAML 5.1 library, which has known CVEs in it. And one of those known CVEs is the RCE type CVE. If folks are seeing an oligo piece on this page, it's because someone might have gone ahead and done that lab already on your test drive instance. So if you need the URL, it's /apps/pygoat/a9_lab. And so this one, you need to upload a YAML file, and the application is supposed to convert it into JSON files. So if you look at the Google Doc file, there's a link to some YAML files that you can use for this. And so feel free to use those YAML files. Feel free to modify the YAML files if you want to try and do something else. The safe.yaml file, that one's not actually malicious. It's just actually going to convert that one to JSON. And so that'll show you what's actually going to happen. The other ones, the name is usually pretty descriptive. So uname is just going to run uname on the instance. The password is going to get the etc password information. SSTI defacement is going to change one of the PyGoat pages in real time. And SSTI restore is going to actually restore that page. So another couple options we can test with there. The other piece, I don't know if folks have explored at all or not, but if you go to the test drive tab, also feel free to explore the different test scenarios that you can execute on the test drive instance itself. And let me know if you've got any questions about any of those. So I am going to interrupt you all, bring us back to the lab. And I saw everyone has been playing around. Lots of people were seeing blocked vulnerabilities in the last 5 minutes or so. I had turned blocking on about 10 minutes or so ago. And so in the command eval or in the YAML upload vulnerabilities, the things that you were doing that were producing output from the system before, now you should be seeing this something went wrong when you did it. So this was the one that was reading from the shadow file, for example. And then in the oligo side now, you should be seeing a whole bunch of these blocked incidents. And that's because the blocking is turned on. And so the malicious actors are no longer able to get that output, to get the access into the system. And the really cool thing is the application still keeps running. The application still keeps going for the intended use cases. So it doesn't bring the entire process down. It doesn't bring the container down. It just gives the defenders more time to be able to manage the situation and not have to impact the uptime, impact reliability. So that was everything for the particular lab that we wanted to run through. The lab is going to be accessible. So if you want to log back into that demo environment that we first started on, that's that read-only demo environment. That's going to be accessible for the next 48 hours. And then the lab environment should be accessible for the next 24 hours. So if you want to go in and play around with anything, check things out, definitely feel free to do that. Feel free to send us questions, ask us questions if you run into anything that you're not expecting or that you just want to find out more information about. Let's see. I did want to talk about, we're going to have a really cool show at Black Hat coming up in Vegas in August. And so some of the security researchers at Oligo are going to be presenting about some of the security findings that they've found. And that one is specifically AI attack related. How many people here, are any of you planning to go to Black Hat at this point? Or there we go, quite a few Black Hat attendees. So we'll hope to see you there in the nice Vegas heat. That's everything from me. Any questions from the group at this point? Great. Thank you all for coming. And I'll pass it back to, whoop. Thank you. Pleasure.
Great. I hope you all enjoyed the workshop. And then thank you for being here, not watching the World Cup, because World Cup was another factor affected our attendees. And I would just like to invite Sarah to come over here and just briefly talk about what Oligo do. Please stay.
Hi, everybody. I chatted with a lot of you guys when you came in. My name is Sarah, and I've been with Oligo for 4 months now. Before Oligo, I was at a company called Anchor, which is an enterprise version of Sift and Bright. I bring that up because that solution, I was there for 4 years, focused very much on vulnerability management, generating SBOMs. It was very much the shift left strategy of security, which I think is really important. You have 10,000 vulnerabilities in the shift left solution. But then with Oligo, you're able to see, well, only like 5% of those vulnerabilities are actually exploitable in runtime. So let's focus on those right now and not chase around theoretical vulnerabilities that are in the thousands. So that's one side. Then the other side is the blocking, which is what we focused on today in this workshop, which I thought was really great. Hopefully you guys got a lot out of it. But really understanding, how do I block something and actually stop it? What if there isn't a patch, right? A CVE means that it is known and there's a known patch available. But what if there isn't? What if a 0 day occurs and you have no idea and you're scrambling trying to figure that out? You can block it with Oligo. And I just think that's super powerful. So if you guys are interested in learning more about what we do and you want to get a more in-depth demo, this was mostly about learning. We didn't necessarily want to pitch you too hard on Oligo, but hopefully you guys saw the value. And if you guys want to learn more about what we do, please reach out. I've connected with most of you that I saw on the sign-up sheet. Connect with me on LinkedIn or just come chat with me after. Hopefully you guys are excited about it. And thanks so much for coming.
Thank you so much. Thank you, Jeff, again. And then at this time, we are concluding the workshop. Please clean after yourself. And then we have to leave in like 5 to 10 minutes, no later than that. So be ready, just start your run exercise and just like move. Exactly, and do some jumping jack. So thank you, everybody. See you next week on Wednesday.